Hi guys, welcome back to my class. Today, in our last video, we talked about atomic structure 1. We looked into the works of the French scientists in the light of Ernest Rutherford, J.J. Thomson, Henry Moseley, their works in discovering the structure of an atom. In my initial video, for those that have not watched, please try to watch the video so that we can move along with us in this new video. Now, today we are going to be looking at the works of this great scientist that is here. Now, in 1920s, the wave mechanics model was discovered, or let's say the wave mechanics model was created by the efforts of these great scientists. Then, they explained to us by telling us more about the probability of finding the electron. That means the probability of the probability of finding the electron inside an energy level. Don't forget that the work of Niels Bohr was to tell us about how the electrons, the movement, or let me say the parts of movement of the electron. But you see, these three scientists, we are not looking into the part or movement of the movement of the electron, but rather than that, they want to explain to us about the probability of finding the electron inside the energy, around the nucleus in the energy level. Now let's look at the work one by one. Let's take a look at the work of de Broglie. Now, what's his own work? You see, de Broglie tried to state a theory by assuming the particle. So they are assuming the wave-particle duality for an electron. What do you mean by wave-particle duality? Made us understand that an electron can have the characteristic of a wave, and also it can behave as a particle. Then it tried to calculate for the wavelength of an electron. That means it tries to calculate for the wavelength of an electron using the mass of the electron. How do we do that? Don't forget that the wave nature of light was stated by Max Planck, about how light is being quantized, the radiation of light. Now, what de Broglie did was that he made us to understand, as in he relates the wave nature of light using the energy of radiation of light with what Albert Einstein stated about how the energy can be related to mass of how the energy of a particle can be related to its mass. Then de Broglie made use of this to calculate for the wavelength of the particle. Now, the particle that we're referring to in this place, don't forget that is our electron. So he calculated for the wavelength of the electron using these two equations. According to Max Planck, E equals to hf, where this h is equals to our Planck constant, and f is equals to the frequency of the wave. Frequency of the wave. But don't forget, in this case here, we are referring to the electron. In this case here. Now, and also, it makes use of Albert Einstein equation, famous equation, which is E equals to mc squared, where its mass is the mass of the electron, and c is the speed. This m is equals to mass of electron, and c is the speed of electron. Now, we try to use this to calculate for the wavelength of the particles. How do we do that? How do we do that? From this point here, it made us know using the wave-particle duality that an electron can behave like a wave. In that case, say that hf should be equals to mc squared, whereby we can easily calculate by saying from here, in this case from here, my f is equal to speed over wavelength. Now, if I replace my f as speed over wavelength, in this case here, I should be having if I replace my f in this place, I should be having h c over wavelength, which is equal to mc square which is equal to what? mc square. Then I think c can remove one c here. I should be having h over wavelength to be equal to mc. Now, do you know that what in mechanics we believe that what momentum of a body can be given as what mass of the body times velocity of the body. The same thing, we can find the momentum of the particles. That means the momentum of the particle, or let's say the momentum of the electron around the nucleus, is given as what this, whereby h over what lambda equals to the momentum. Simply means my wavelength is equals to Planck constant over the momentum. This is what now about calculate. De Broglie calculate. He calculated for the wavelength of the electron by relating the what Planck equation, Planck energy radiation equation, and what about Einstein's equation to find the wavelength of the electron in relation to the mass of the electron. Now, due to that, just to tell us about the probability of how the electron, to tell us more about how the electron is moving and where we can get it. Now, we believe that now the electron that is revolving around the nucleus in its own energy state, has the wavelength, and the electron is moving with what? With the wavelength of h over what? The momentum. That means we can calculate for the wavelength of that electron using this. Then, this scientist came about with what? Okay, if you know the wavelength of the electron, how possible can we get the electron where we think it's going to be? Then Heisenberg stated his own words. Principle. Heisenberg principle was known as what? An uncertainty principle. What does it say? It said that what? It is impossible to know the momentum and the position of the particles. Or let me say, it is impossible to know the momentum and the position of an electron simultaneously. Simply means, if you know the momentum of an electron, then you can never know the position of the electron. This is theory. Heisenberg's theory said that what? It is impossible to locate the moment, to locate what? The position, and momentum of a particle simultaneously. That means we can never know the position and momentum of a particle at the same time. Simply means if you know the position of a particle, okay, I know that what the particle is found here, I can never know how the particle is moving. At the same time, if I know how the particle is moving, it will be difficult to know where exactly is the particle. That is why their own laws is trying to tell us about what the probability of finding the particle, of the probability of locating the particle where they are. Altogether, now in this case here he has stated his own law by using what? Heisenberg principle give us a theory about this calculation of what? Change in momentum of a particle times change in position of a particle is greater than or equals to h over what? 2 pi. That means when you can never know the position at the same time know the momentum. If you know this one was unknown. If I know this one was unknown. That was what Heisenberg principle. Then a scientist came, which is known as what? Erwin Schrödinger. Erwin Schrödinger also tried to explain to us about the position, or let me say, to tell us more about what probability of finding electron round where it is meant to be. Now, what does Erwin Schrödinger explain to us about what? Electron. He stated his famous equation. Through his famous equation, by giving us that what? In this case here, I have something of this kind, that my H, which is equals to E. Now, in this case here, this is the famous equation of what? Henry Schrödinger. Now, what is this equation trying to tell us? In this equation, We know that where this H represents what? Hamiltonian what? Hamiltonian operation. Hamiltonian operation. Why this is what? The wave function. The wave function. The wave function or the probability of finding the electron. We call it the wave function or probability of finding the electron. That's what this one is. Why this E represents the energy of the electron, that we have. Now, according to him, he said the summation of the wave function with the volume is equal to the what? Is equal to position. The summation of the what? Wave function. The summation of the square of the wave function with the volume give us about what? Tells us about what? The probability of finding the electron. That means through his own equation, give us what? The summation integral of the wave function times the v equals to 1. Now, what does he say? What is he trying to say? He now give us what? He said what? The summation of the square of the wave function times the volume tells us more about the what? Where the electron can be located. Now, what I say? In other words, you see, the region of maximum probability of locating the electron is known as electron cloud. The region of maximum probability of locating the electron is known as what? Electron cloud. Electron cloud. Another name given to this what? Electron cloud is otherwise known as what? Orbital. Orbital. Now, it simply shows that what? Orbital, an electron can be found in an orbital round inside what? An energy level. What he's trying to say, let me just try to break down everything that I'm trying to say. You see, Nobel made us to understand that what energy atom can be what? Divided into energy level. That's what he's trying to say. Atom is being divided into what? Energy level. Are you getting what I'm saying? Now, inside each of these energy level, that was what all these ones was trying to explain to us. Now, inside energy level, the energy level is further what? Divided into different parts. The energy level is further divided into what? A sub-energy level. After the energy level is divided into what? A sub-energy level. Then the sub-energy level is now further divided into orbital. Inside the orbital, that is where the electron is located. That's where the electron can be found. Now let's try to what? Let's quickly brush about. We turn back to what Nobel is trying to explain to us. According to him, I think he gave us that what? The maximum electron that an energy level can contain. The maximum electron that an energy level will contain is given as this 2n squared. Where this n represents the principal quantum number. You see, this principal quantum number is just an integral value. Simply means it can have a value from 1, 2, 3, 4, 5. Now, this principal quantum number denotes the energy level. Don't forget that according to Nobel, we have the first energy level, the second energy level, the third energy level, the fourth and the fifth, like that. So, Nobel made us to understand that the maximum number of electrons that an energy level will contain will be equal to this formula, 2n squared. That is the maximum number of electrons that an energy level will contain. Now let's try to break it down into different things. What he's trying to say is that that is when n, which is the first energy level, n, don't forget I said this principal quantum number tells us about energy level, represents the energy level. Now if n is equal to 1, it represents the first energy level. Don't forget that we can call it energy level or shells. Shells. Now, hereby we have different shells. We have the K shell, the N shell, the M shell, and the N shell, N, O shell, P shell, like that. We have different shells. Are you getting? Atom consists of different shells. Now, if N is equal to 1, then we represent the K shell. Now, what we want to know is that how many electrons can the K shell contain? What is the maximum number of electrons that the K shell will contain? What is the maximum number of electrons that can be contained in the S shell? What is the maximum number of electrons that can be contained in what? M shell? And what is the maximum number of electrons that is contained in what? In N shell. This is how we go about it. From here, don't forget that what? Now, Bohr has already discovered that what? The total number of electrons, maximum number of electrons that each shell will contain is equal to 2n squared. From here, if n is equal to 1, then the K shell should contain 2 brackets 1 squared, which equals what? 2 electrons. The maximum number of electrons that the K shell will contain is equal to what? 2 electrons. Now, while the N shell should contain 2 into bracket 2 squared, that means, don't forget that for my L shell, N equals 2, which is your L shell. Now, the L shell should contain 2 into bracket 2 squared, using this formula 2n squared. 2 into bracket 2 squared, which equals what? 8 electrons. 8 electrons. That means the L shell is going to contain 8 electrons, while when n equals to 3, I have the N shell. The N shell. Now, the N shell will contain 2 into bracket 3 squared, which is equal to 2 times 9, which will give us what? 18 electrons. 18 electrons. While the N shell should give us what? 2 into bracket 4 squared, which is equal to what? 2 times 16, which gives us to 32 electrons. Please, don't forget. If you watch here, I said what? The K shell is going to what? Contain 2 electrons, the N shell will contain what? 8 electrons. How do we get the electrons? Don't forget the maximum number of electrons that a shell can contain is equal to 2n squared. So these are the what? Possibilities that the total electron that a single shell can contain. Don't forget something that what? According to Erwin Schrödinger, you with me? According to what Erwin Schrödinger, it made us to understand that what? The maximum probability of locating an electron, maximum probability, or let me say, a region with the maximum probability of locating an electron is known as orbital. That means the region with what maximum probability of locating an electron. We call it what? Orbital. It simply shows that what each of these electrons can be found in an orbital. What does that mean? What is trying to make us understand is that the atom contains a shell. It consists of a shell. Inside a shell, we have a subshell. Inside a subshell, we now have what? Orbital. Then, these electrons are found inside and what? An orbital. Thank you for watching. Please don't forget to subscribe to my YouTube channel. In our next video, we'll look into what? Quantum mechanics. Please try to watch the next video so that you can what? Get more knowledge on quantum numbers. My next video will be looking at what? Quantum numbers. Please don't forget to subscribe to my YouTube channel. And when you subscribe, please try to click on the notification bell to notify you when we release new videos, and also try to like my videos and share. Thank you very much. We love you.